Our theme today, we've talked a lot about reliability. So next up is our panel called Reliability to Thrive. The moderator for this panel will be Andy Buntrock, Vice President of Strategic Planning and Communications. Andy?
All right, we'll get started here. We're still working on Mike and everybody up here after the transition, so we appreciate your patience. Just wanted to welcome everybody here. Like Kermit said, my name is Andy Buntrock. This is the Reliability to Thrive panel. And here I'm going to introduce today some of the best and the brightest coming out of Basin Electric. We've got Erin Dukart, which is Director of Environmental Services. We've got Troy Tweeten. He's our Senior Vice President of Operations. We also got Trinity Turnbow, who's the Vice President and Operations Manager of Dakota Gas. Then we've got Matt Ehrman, who's Vice President of Engineering and Construction. And finally, I got the famous Jeremy Severson, who is Vice President of Transmission and who also is a crack shot at golf, I understand. So if everybody remembers, we usually, Tom Christensen from Transmission is up here, and he and I kind of banter back and forth with his hairstyle, but I promised Jeremy I would not bring up anything like that to embarrass him, so we'll stay away from that topic today. But we just wanted to thank you all for coming, and most of all, just thank you for the support you give and the hard work that you give to serving your co-op, and then especially our co-op, Basin Electric, as all of us are part of it. So to kind of begin things, we've got a lot of proposed regulation coming out. I think the panel that was up here just before went through a tremendous amount of that, and so we're going to touch on that just lightly. But as I was listening to that panel, it reminded me of, we did a survey, sometimes we call it the member survey, but Paulson Group out of Sioux Falls, South Dakota helped us do it. But we did that probably about 3 years ago, and if you remember, the number one and number two things that you as the members told us that were important to you was reliability and affordability. And so as we're thinking about this, I just think about how do those regulations that are coming forward impact the two things that you told us were most important. So with that, I'm going to turn it over to Erin. And I believe we have a slide here, Erin. And this slide is called the train wreck slide, I understand. So can you fill us in on, I see some people in the back are like, what in the world is that thing? So Erin's going to tell us all about this train wreck.
So this is our new train wreck slide. It illustrates the increased and proposed regulations that we're seeing from EPA for air, water, and waste, targeting both coal and natural gas generation. And of all these regulations, the biggest risk to reliability is likely the proposed greenhouse gas rules. The 111D rule targets existing coal and natural gas generation. Specifically, under this proposed rule, existing coal would need to install carbon capture and sequestration equipment by 2030 or close by 2040. Large existing natural gas combined cycle generation would need to either co-fire 96% low GHG hydrogen or capture 90% of the carbon emissions from those units. And EPA has said that they are giving utilities lots of flexibility because there are all these multiple pathways to compliance. But in the end, it doesn't really matter how many pathways there are if none of them are workable.
Okay, so Erin, that was what you were just talking about is the existing generation, correct? And why don't you tell us a little bit about new generation? Obviously, Basin Electric is building a lot for its members, but what's going to happen there with the new gen?
The 111B rule would set the standards for new generation, and under that new proposed rule, new simple cycle generation would be severely limited in how much it would be allowed to operate. Baseload new natural gas generation would either need to co-fire with low GHG hydrogen, which is not available, or again, capture 90% of its carbon emissions, which is not feasible.
So I want to get this straight here. So if we're going to build new generation, we got some options, they're saying. And those options, if I'm understanding this correctly, would be to either burn hydrogen at a certain percent, and I'm assuming we've got technology that's in operation right now in order to hit these targets?
For turbines, depending upon the technology, there is a difference in their ability or what percentage of hydrogen they can burn. However, regardless of the technology, none of it is to the level that EPA is expecting.
Okay. And so then I struck out there. How about my other one? You said carbon capture up to 90% on these natural gas units. I'm assuming that technology exists. We should be ready to roll out. That should be a go-to.
We're working on that technology, but it is not currently commercially available.
Okay. You're not giving me warm, fuzzy feelings here, Erin.
So while the regulations pose a threat to reliability and Basin Electric's ability to provide low-cost electricity to our membership, we are not alone in this struggle. We are working with trade organizations like NRECA and the Lignite Energy Council. We're working with regional transmission organizations like SPP, as well as other utilities to push back and educate EPA as to why these regulations are not workable.
So I wanted to borrow a quote from a former Basin CFO, Buzz Hudgens, if some of you remember him. And when I was thinking about this as we were talking through it, I wanted to say, have we seen this movie before, Erin?
We have. We have been in this position before, and we have navigated it successfully. This is the new train wreck slide. It is not the first train wreck slide. As previously discussed, the Clean Power Plan is a good example of how in the past EPA has imposed improper regulations that have been stayed and then ultimately pulled back. And while we are pushing back on EPA and trying to educate them, we are also preparing for legal action if necessary, and we're looking at innovative ways to decrease our emissions and operate even cleaner than we do now.
All right. Thanks for the explanation, Erin. Now let's turn to Troy. We've got our Dry Fork Station, which is near a coal-fired unit near Gillette, Wyoming. It's our most recently commissioned coal-fired unit, and I know we got some interesting stuff going on out there on the carbon front. Troy, can you kind of roll that out for us and explain what Basin Electric's doing out there to impact some of this carbon side of things?
Yeah, sure. I probably should have brought Wyoming Governor Gordon back to talk about it. He was talking a little bit about it already. But at Dry Fork Station, we have the Integrated Test Center. This was a joint effort between the state of Wyoming, Tri-State G&T, NRECA, and Basin Electric. And it was designed as a research and development for new ways to test CO2, bring it in off of a bench test, and put it into the field and do live field testing, capturing the CO2 out of a stream gas from a coal plant or even natural gas, which we can simulate that. And just new ways to capture that. And then along with that, when we first started, we had the X Prize competition that came in, and that was strictly for ways to come up with new innovative ideas on how to use CO2. It had to be totally different, something that it was not used for. We had that competition. COVID kind of interrupted that a little bit and kind of put that on hold, but they still went through the competition, and through that we had Carbon Built. It was from UCLA. They were the winners of that competition. We've had multiple other universities, independent companies that have come in and want to test at the site, and we have the 5 small test bays. There's a large test bay center there, and currently MTR, which is Membrane Technology Research, they're going to use the large test bay area to do some research on CO2 capture with their system. And then we also have J. Cole and KHI, which is Kawasaki Heavy Industries, and they're also setting up to do some testing there. Another thing that we have going on down there at Dry Fork site is Carbon Safe, and that's in an effort with the University of Wyoming. And that is for drilling the sequestration wells and trying to do some testing for carbon storage and the potential of having a hub in that area for gathering the CO2 and injecting it underground. So one thing that I would say is, you know, it's been talked about, it's coming up with all these new ideas and ways to test it, and we're looking for somebody to have a proven effort to meet these new EPA regulations. And so once it gets developed, yeah, we'll look at installing those, and we're more than willing to jump on board and do this. But if we do add something like that to one of our facilities, it's going to be multi-year effort to have that completed. So it's not something that can get done just right away.
You know, sometimes I think co-ops are inappropriately framed as being slow to move, and you know, I'd argue that point and say that I almost think it's the opposite. I look at, if we shift gears a little bit here down to DGC, I look at what we've been doing out there as a cooperative since year 2000. We've been capturing CO2 there, and as you know, compressing it and shipping it up to Canada for enhanced oil recovery. And so fast forward 23 years later, and now you hear a lot of people are talking about carbon footprint and things like that. And you know, I kind of mockingly say, you know, thanks for coming to the party. You know, we've been here for 23 years. So, you know, with that said, we'd like to hear a little bit from Trinity on what's going on out at DGC and with 45Q, and give us an update on that.
Yeah, Andy, you mentioned the CO2 we've been sequestering since 2000. Well, the 45Q project is a project where we will inject additional CO2 locally, so it's close to the DGC site on Coteau property. And this project is one that captures and sequesters CO2 not sent to Canada. We currently burn it in our boilers and emit it, so we will capture a portion of that and put it underground very near DGC. We are expecting a Q1 of next year, 2024, construction complete and startup, so very soon. And this project will reduce the carbon intensity at DGC and provide another enhanced revenue stream for us.
So how many wells are you talking about out there, Trinity, and how many miles of pipe, what pipe size? You know, fill us in a little bit on some of the details.
Sure. There will be 6 wells that we will be injecting in. At any given time, we will likely be injecting in 4 wells. Simultaneously, we'll leave 2 wells as spares, so that if we ever need to do any work on a well, then we can switch to a different well without having any downtime or reduced CO2 flows. The total pipe, like I said, it's very close to the DGC site. It's about 3 miles of 12-inch pipe. That's the main header that'll run north of DGC. And then there's about 4 miles of 6-inch pipe. Those will be the branches to those 6 wells.
So Trinity, how deep is the CO2 once you inject it into the well, and how do we ensure that it doesn't migrate or leak back up?
Yeah, the CO2, the wells themselves will be about a mile deep. It'll go through several layers of impermeable hard rock, and the CO2 will be injected into a saline aquifer for permanent sequestration that'll trap it underground. The wells themselves we will monitor the operating conditions of those wells and have the capability of isolating any well should there be an unforeseen issue. On the pipeline itself, we call it an LDS system. It's a leak detection system. It's the same system we have on our 200-mile pipe going up to Canada. And that also monitors in real time various operating conditions and reports back immediately any anomalies. We also have the ability to remotely isolate various valves to block sections if we were to need to do that. But it should be noted, Andy, that in the 20-plus years we've been operating our pipeline to Canada, we have never had an in-service CO2 leak.
All right. Thanks very much, Trinity. I want to shift gears a little bit to generation. We talked about the importance of reliability and affordability, and we're going to lean on Matt a little bit here to kind of talk about what the co-op is doing in order to ensure those two strong building blocks are in place on the generation side.
Yeah, thanks, Andy. A few of the things I'm going to talk about kind of sound basic, sort of 101, but I think the key is doing them consistently. We begin incorporating reliability into the design from the very beginnings of any project that we work on. We mitigate potential reliability concerns for the members by beginning with selecting good sites for any of the projects in new generation, sites that have reliable transmission, water, fuel supply, those types of things. We also try to stick to proven designs, and we use commercially available equipment with good proven track records. And we also strive to incorporate redundancy and try really hard to eliminate any single points of failure in any of the designs. And another thing with the kind of supply chain things going on, it's become sort of even more important, is to make sure that we have all of the necessary critical spares on hand, and in addition to that, the warehouse space to store all those spare parts.
I think the way you're treating the spare parts is no different than some of the farmers that we have in our membership, and having spare belts and spare cutting bars and things like that for their combines. So when it's time to go, you're ready to go. And in this case, it's when it's time to generate, the units are ready to go. So I appreciate that.
Yeah, that's exactly right, Andy. You can imagine for a large generating unit, just the amount of spare parts you need to have in hand. At our Pioneer Generation Station, the Phase 4 project that's under construction, we're actually currently adding a whole new warehouse up there to store those spare parts for both the additional parts for the existing units, plus spare parts for the new units as well.
And so when you guys are laying out these areas or targeting these future areas, Matt, how do you even go about doing that when, like the previous panel was talking about how much things change constantly? The bogey is always moving on us. How do you guys roll that out to ensure that we're in good position?
Yeah, well, we never know quite exactly what the future holds, but we do try to incorporate flexibility into all of our designs, which tends to improve the reliability. So we try not to box ourselves in a corner when we're laying out a site. We try to leave room for things like additional units or expansion. We're thinking about emissions controls that might be coming down the pipeline, things that we might want to leave space for, such as the carbon capture that we've talked a little bit about today. All those things we just try not to box ourselves in a corner, and that flexibility really allows us to respond to those future events quicker, which ultimately provides additional reliability for the membership.
I wanted to talk just a little bit about the Pioneer Generating Station Phase 4. I think Gavin had mentioned this earlier, but I think we got a video that while we're discussing this, and Matt's filling us in on it, that kind of flies through the site. But I think this is one of our biggest generation builds since the 80s. Is that correct, Matt? Can you tell us more about it?
Yeah, that's right. So Pioneer Generation Station Phase 4 is, of course, in addition to our existing Pioneer Station. We already have 12 of some smaller 9 megawatt reciprocating engines on site, and we have 3 simple cycle gas turbines on site, just about 45 megawatts each. We're adding 6 larger 18 megawatt reciprocating engines and 2 large frame simple cycle gas turbines. And when construction's complete, it's well underway. What you're seeing there is a rendering But when it's all complete, we'll be adding 600 megawatts of additional generation to the site.
And there's two types of generation there, right? The way it sounds, can you tell us a little bit more about that, those technologies?
Yeah, we have there's, like I said, there's two technologies on the site. We have reciprocating engines and gas turbines. We already had them both previously, and we knew the reciprocating engines were fast, reliable, flexible units, and so we knew we wanted a few additional of those engines on the site. But since we already have quite a few smaller units up in the region, in the Bakken there, we knew we wanted to balance those smaller units with a couple larger, bigger turbines as well. A benefit of that, of both technologies, they'll also pair nicely with all the renewables that are getting added in the area up there. And because we have two technologies, they're also being sourced. The equipment's coming from different parts of the world, all to the project site. So we do take some comfort also, some peace of mind in knowing that they are coming from different areas, different things going on with supply chain. Again, not all of our bags, all of our eggs are in one basket in terms of delivering that project on time and providing reliability for the membership.
Alrighty, thank you, Matt. So Matt really covered the generation side of things, but obviously you can't have generation without transmission because you need to be able to get the gen to load. So we're gonna lean into Jeremy a little bit here to tell us about what's going on the transmission side of things. So,
Andy, I'd just first start that this hair comes from 35 years of using the Flowbee, so But when I think of reliability, and it's been mentioned several times today, I think of the consistent and available electricity. That when I flip that switch, the lights are coming on, my Flowbee works, it's there. And electricity is such a unique commodity. It has to be created, transmitted, and consumed all in an instant. It's like nothing else. And the middle part of that equation is the transmission of the electricity across the transmission system, the grid. And having a strong, robust, flexible, and available transmission system is the key to reliability. And I said availability because availability is key. And most of our transmission is highly available, sometimes 99, 100% of the time. But there are times when transmission comes down and it has drastic effects on congestion, load serving capability, getting our generation on. So when transmission comes out of service, either planned or unplanned, we're always trying to do what we can do to get it back. If an event is unplanned, we've got 11 different transmission system maintenance outposts across our 9-state region to respond and react and get that transmission back in service. If an event is planned, there's an immense amount of coordination between our generation, our members, our transmission operators to make sure that events, when they do occur at the least impactful time. And one thing that our basin has is our transmission maintenance is trained to do hotline work on high voltage transmission lines. We're one of the few utilities in the region to do that hotline work. And in doing that maintenance is key to continue our reliability for our aging infrastructure.
So, we hear a lot about that in the news, Jeremy, the aging infrastructure. Can you tell us what is Basin Electric and their cooperative doing in order to ensure that, as our structures age, that we're taking care of things and they'll be around for decades to come?
Yeah, so you mentioned our aging infrastructure, and we built a lot of our transmission back in the 70s and 80s when we put in a bunch of our generation. So several years ago, we took a systematic approach at Basin to sit down with a team of Basin members and identify our substation facilities that had equipment that was reaching the end of its useful life. And we've taken a systematic approach to identifying which facilities are the most impactful and replacing some of that equipment, like oil circuit breakers, electromechanical relays, and replacing that with newer technology to make sure that those facilities will be reliable for the next 40 to 50 years. In addition to that, we're also undertaking a large transmission build-out in our region. I believe if you go to the next slide, it touches on our large transmission build-out. And this infrastructure was identified to serve the increasing load-serving needs up in this region. And I'd be remiss if I didn't say to check out the booth in the back. Bobby's got a great slide deck, walks through all of our transmission build-out through this region. But this additional transmission will increase the load-serving capability of the area. It increases the transfer capability up into this region. It will allow additional loads or generation. And it also lays in a couple new delivery points for our members. And that adds in redundancy to their load-serving capability. One interesting thing about this area, this transmission build-out, we're using a new conductor, at least a new conductor for Basin. It's a carbon core conductor that's got some very unique properties. One of the properties, has a very high ampacity that we can shove a lot of power down these lines. And the other property, it's got that carbon core conductor, which makes it very, very strong, and we can string it very tightly. And due to that tight tension, it has a lower ellipse during galloping situations. It reduces those phase-to-phase touches and should increase the reliability in the area. So that we're excited about that. So there's a lot of transmission going on. Our grid is evolving as the energy mix changes, and I think you'll see additional transmission in the future across our service territory. So Andy, I guess to summarize, and I may be biased, but transmission is a key aspect to us having the ability, if you want to use a Flowbee, turning the light switch on to that continued reliability in the future.
It's like the chicken or the egg there, right?
Yeah, I guess so. So I appreciate it, Jeremy. Since Troy spoke up, we're going to drag him back into this. So we want to talk a little bit about existing generation. And there's a map in front of you there that shows the family of the family-owned generation facilities that we have, and these truly are the backbone of the reliability piece that the cooperative is able to provide for you, and it really is the value proposition of being part of a large network and a large family to lean back on to ensure that reliability and ensure that affordability. So with that said, we're lean back to Troy here a little bit and say, kind of what are we doing in order to keep these units running so that they're ready, if going back to my previous analogy, when harvest comes, we're ready to roll.
Yeah, and looking at the map, you can see there's all kinds of different types of generators. And then even with the different types, it's pretty geographically diverse, so that if wind is blowing in one area, you don't necessarily don't have any generation there. We have some in North Dakota, some in South Dakota, a little out further than that, but it definitely helps with that reliability when bad weather comes, or even if it's hot, and whether it's hot or cold. Other things that you've heard everybody talking about all day long is with our reliability and availability. And in all of these generating stations, they all have a lot of moving parts. I don't know if you've been on a tour to any of the facilities, but it takes a lot to generate power. And any of them moving parts can fail and take a unit offline. And so some of the things that we're trying to do is we're using lesson learned. One of the things we've developed is it's called an outage and cost analysis report. And what we do is we review that, and we're trying to make sure that we can take care of repeat offenders, as some system that keeps going down and causing problems. Well, we're going to try and do a little bit more research on that and see ways we can improve it and then make it more available, more reliable and available. We've also been in the process of increasing our warehouse inventories. We're looking at more common parts that can be shared between other facilities. Everybody still sees it. I don't know if everybody uses the COVID excuse anymore still, but can't get parts, can't get a lot of different things still. and we're still running into that. But those are other ways that we're trying to make sure that if something breaks, that we have it in our warehouse or at least at another site. Other things that we do, we do our planned outages, and those are usually done on the spring or the fall, but we have some in the shoulder months in the spring and fall where the power's not necessarily needed. Do some maintenance there, make sure that everything is repaired so we're going into the summer or winter with a good run availability, hopefully. And we have other things that software that can monitor systems, and might be something that happens super fast that an employee won't see while they're sitting there at their desk, but we get alarms on it, we can catch it on trends. That helps us monitor the systems. We have remote operations for our gas and wind parks, and those can help so that if we need to run them 24/7, which has been happening quite often anymore with those units, is with the gas units especially, having to run them 24/7. So it's a lot of effort put in there by the employees and everybody.
And then you've got an example here of a lube pump, right? I believe that you've got a story for us on.
Yeah, so this was at AVS Unit 2, and I should mention that all our employees, they definitely take a lot of pride keeping the plants clean, keeping them running, keeping them reliable. And this is just another one of those examples. We had what's called a primary air heater, and that takes some of your ambient air temp, brings it into the building and into the unit, and preheats it up. It's used for drying the coal, transporting the coal, and it had an internal lube oil pump on it, a shaft-driven pump that failed, and we were going to have to take the unit off to repair it. And they came up with this transfer pump and just plumbed it in. We were able to keep the unit online for a little bit. There's a sump in there that still kept the bearings cool, but within a couple hours it was going to have to be taken offline. And middle of the night, I think it was around 2 o'clock in the morning when they came up with this idea to plumb in a transfer pump. We were able to keep the unit online, and then we still ran it and took it. We swapped out that pump then on what we call an opportunity outage, the day when there was low power, low load, and there was extra wind, and so we could take that unit off and do it at an opportune time.
Then I jumped the gun a little bit here, but you had a story too. I think Gavin had shown this picture earlier on a part out of LOS. Can you tell us about what happened here and what the team did? Yeah,
this is another classic example, and Gavin had some really good pictures in his report earlier on this. It's kind of deceiving. This was, as he mentioned, it was from the exciter. It's a connecting lug to the generator so that you can apply the field to the generator. And we had a ground fault in that. And you can see it looks like about 4 inches of that copper had melted off. Well, that's about 4 inches wide, 4 inches long, and about an inch or inch and a half thick. And it just instantly just melted that and vaporized some of it. And when that happened, of course, it took us a little bit to find out what happened. Once we figured it out, then we started looking for a part. Well, after they get looking into it, couldn't find any drawings on it, and contacted the OEM, the original equipment manufacturer, and tried getting some information from them. Well, it turns out that was supposed to be a lifetime part that was designed for the unit. They didn't think they would ever need that again. So they were going to have to try and redo the drawings, dig stuff up, and this is one of the things that I am very proud of our employees. They used some reverse engineering and good old farmer ingenuity, and they found some copper bars that were located in some breakers off the old Glen Harold mine that was shut down. Got those over, drew everything up. They had the one good one there next to it that they used as a model, and they had some assistance from one of the contractors that helped silver solder it together, and we were able to get that thing put back together and back online. It took us 2 days instead of weeks of trying to find that part. So this is a picture of the team that's up there right now, and a very good story on a team wins. And we actually did have a video on that we shared throughout the cooperative, and I think even with some of our members on that.
I love hearing those stories. It just shows how the employees out there really just lean into it. You know, I think in past years we talked about a story out at LOS at the switch yard when that unit was down and badly needed because there was issues in the switch yard, and they were out minus 30-degree weather, you know, getting that thing back up and rolling. So we just really appreciate that with the employees and the ability they can just take some basically scrap there and build a part that we need desperately at the time. So.
Yeah, the only other thing just to add on that, you know, when I said that was a lifetime part, and it truly was. When that unit was off LOS Unit 1, and it was put into service in 1966. The original design was 35 years on that, and it lasted 57 years. So it definitely did a good job.
That's great. And we know we got DGC is obviously right across the fence from Antelope Valley Station, and Trinity, you've got similar stories out there, but can you fill us in about what things are going on out at DGC?
Yeah, we've got a major step in our reliability program coming up just next month. We've got what we call a brown plant outage. And in this outage, we will be focusing on a lot of reliability projects that will help improve our gas path online factor, which will also help us maximize the potential of the 45Q project I mentioned just a little bit ago. During this outage, well, at first I should say brown plant means to us. And brown plant means everything will be down except for some utilities, steam, air, water. And the total duration of the outage will be about a month, with the first week will be half rate, so we'll have half the plant up, and the last 3 weeks or so the entire plant will be down. And during this outage we'll have several original pieces of equipment and piping that will be replaced, and so we're talking 40-year-old equipment, similar to what Troy was talking about, and those will certainly help with reliability going forward. We're expecting to complete over 4,000 work tasks, so a lot of work happening. To get this done, this will take all of our internal resources. Basin Electric resources are helping us out, and we'll have upwards of 400 contract personnel on site. Also during this, we'll have extensive coordination just with our marketing team in order to ensure as little disruption to our customers as possible. So we're going to do as much preloading as possible of various commodities and then distribute our shipping throughout the month to minimize any impacts there. So in order to really get this done, obviously we need our people and our contractors to complete this outage, and we'll need everybody to do their best, and I'm fully confident they will.
Now, I understand this spring the urea plant was one of the few in the regions that were running, which obviously benefits not only the membership but also the farmers as well. Can you tell us about that?
Yeah, and you know, it goes far before this spring to get there. We've spent a number of years focusing heavily on improving the reliability of our ammonia plant, and then with the addition of the urea plant, also on the urea plant. And over the past 5 years, we've increased production online factor of both ammonia and urea, and we've improved our loadout reliability, which includes the people that do the loadout. They've become unbelievable at being able to load out quickly and effectively and with the quality that our customers demand. And as you know, you can produce all you want, but if you can't load it, it doesn't really matter. You can't get it to market. So that's just as important as producing it. This all led to last year where we had all-time record highs in anhydrous ammonia and urea production. That set the stage for this spring, allowing more inventory for this spring. And then we ran really well. They operated both units really well throughout the outage, and loaded product really effectively. And we were able to be there during spring for our customers when it mattered most. And I think Troy would agree that when you invest in reliability like we have in these units, you will see results.
Thank you, Trinity. Early on in my cooperative career, I had the opportunity actually working with Valerie Weigel. Her and I had the opportunity to work with the plant basically on a daily basis, so you got to know these people really well, the operators, the maintenance, and you talk to them on Christmas Eve morning and Christmas Day, so you got to know them really well, and I was just always enthused and it just blew me away at the ability to when a problem arises, no matter how big or how small, the drive to, we can get this unit back, we can pull this around, we think we can do it faster than what we're estimating, and that just always really impressed me. So I think for all the, not only DGC and Basin Electric employees that are watching this right now, I'd just like to really thank you for what you do for the family and all your hard work. You know, we've covered a lot today. I think, you know, I hope this panel, we covered basically a wide variety of topics. I hope this panel leaves you with the idea that the units that you've entrusted us to operate for you and to build in cases, and the transmission that we've built is being done efficiently and effectively, and that you know, we're doing the very best we can for the membership. So I know all of our panelists will be around tomorrow for the members only meeting. So if you got any questions for them, we can talk about it at that time, but we thank you for coming and we thank you for your time. Appreciate it.